Hi everyone. Today we're going to take a look at solving logarithmic equations, and we're going to solve this particular equation here using a method that I'm going to call the Krull Method. Okay, and I'm going to call it that in deference to the gentleman who suggested that this is how I teach it to students. I'm not going to suggest that what I'm showing you here is the absolute best method. It's not even perhaps even the best method for this particular question. It is, however, a method that works all the time. And so I think it's a good one to look over here. And what this colleague of mine suggested that we do here is the very first thing that we're going to do is bring all terms that have a logarithm in them over to one side. So that'll make this 1/2 the natural log of 2x plus 4 minus the natural log of the root of x plus 1 minus the natural log of 1/2. And in this case, there are no other terms here, and so the other side of the equation is just going to be 0. Okay? Now, the next step in his particular method here is to combine all the logarithms into one logarithm, and that is probably the most important kind of defining feature of his method here, because in a lot of cases where people get confused when you start approaching logarithmic equations, trying to set it up differently, the different ways it looks, and blah blah blah. Sometimes it's very easy to lose track and to start applying the logarithm laws incorrectly. So what we want to do here is get it all into one logarithm, okay? And that should be possible in just 2 steps, okay? So I should be able to get one logarithm in 2 steps. The first step is going to be to move any coefficients up as exponents. So this right here is going to be to the 1/2 minus, and I'm just going to rewrite this radical here as x plus 1 to the 1/2 minus the natural log of 1/2 equals 0. So there's my first step, is to deal with the coefficients. Now, this is just a matter of applying the laws of logarithms here, remembering that subtraction, I should say, subtraction becomes division. Okay, so subtraction between logarithms becomes division within a logarithm. Now, you have to do this in the correct order. I've watched so many people start with a subtraction, and I don't know why they do this, but they go backwards with this, and they go, well, this is divided into this is divided. No, this way. Okay, so this becomes the natural log of 2x plus 4 to the 1/2 divided by x plus 1 to the 1/2, and then I'm going to divide. Okay, I'm going to divide by by 1/2 here, but it's not the x plus 1 to the 1/2 being divided by 1/2. Okay, it's this thing right here. Okay, I'm dividing by this, and I'm dividing by this, so that's why that 1/2 also goes into the denominator. Okay, essentially anything with a negative sign in front, that argument will end up in the denominator. Anything that has a positive sign in front, okay, that argument will end up in the numerator. It's just a nice shortcut way of dealing with it. Now that you got it into one logarithm, okay, now this is a logarithmic equation, okay, I'm starting with logs in the equation here. The goal when solving a logarithmic equation is to get rid of the logs. So at this particular point here, now that we've got it at one logarithm, I'm going to get rid of the logs by converting to its exponential form. The base of the natural logarithm is e, so this will become e to the 0 is going to equal, and I'll put the radicals back in because at this point it's probably a little bit easier to see at this point. And I'm going to bring that 1/2 up front, root x plus 1. Okay, now we know that e to the 0 is just going to be 1, and then I'm going to take that denominator and move it up, and so this will become 1/2 square root of x plus 1 is going to equal the square root of 2x plus 4. Okay. And now what I'm going to do here, I've got radicals on both sides. You know what? I tell you what, I know a lot of people are going to want to do this anyway, so I'm going to do the same thing. I'm going to get rid of that 2 in the denominator. I'm going to multiply that up. So I've got the square root of x plus 1 is equal to 2 root 2x plus 4. Now I'm going to square both sides of the equation to get rid of the radicals. And so I'll get x plus 1 is equal to 4 times 2x plus 4. And now this is just a basic old polynomial here. In fact, it's not even all that complicated. It's a linear. So multiply through, get 8x plus 16 And I'll bring that x over to get 7x. Bring the 16 over, so 1 minus 16 is going to be negative 15. And divide, and I get negative 15 over 7 is equal to x. Now, what I got to do here is I got to go back up to the original function and check and see, does that work? Is it possible to plug that up in here? Well, okay, negative 15 over 7 is going to be a little over 2, right? Because, I mean, negative 14 divided by 7 would be negative 2. So that's going to be like negative 2 here. If you plug that in right here, you're going to get negative 2 plus 1, negative 1 squared. Well, that can't happen there. So after all this, we would go down and say, well, you know what? There's no solution, because that particular value simply doesn't work. And that's not a problem at all. It is totally okay to have no solution as the solution to your problem.